Hi there, welcome to my channel Mandu to Fundu. In this video, I'm going to discuss about the solution for doing level order traversal on a binary tree. Let's look at the problem description. We are given a root of a binary tree and we have to return the level order traversal of its nodes value. Basically from left to right and level by level. So for this tree, it is 3, 9, 20 and 15, 7. Considering the number of nodes in the tree is in the range from 0 to 2000 and the values will be ranging from -1000 to 1000. Let's look at the approach to solve this problem. So we have a tree 1 2 3 null 4 null 5. So we have to return 1 comma and then the second list 2 comma 3, third list 4 comma 5. So that is the output we have to return. So in order to do the level order traversal, we need to use the queue data structure. So what that queue data structure will contain is before entering each level, it will contain the elements to be processed for that level. For example, when the program starts, initially we put the root node in the queue and then there will be two nested loop. The outer loop will check whether the queue is empty or not. If it is not empty, it will get the current number of elements in that queue and then dequeue that many number of elements in the inner loop and then add it to the current level list. That current level list will be added to the out list, which is so that current level list is added to the out list at the end of each outer loop iteration. So inside the inner loop, for each element dequeued, we have to add that to current level list and then we have to check whether that node has a left child. If so, add that left child node to the queue. Same thing, if there is a right child, add that right child to the queue. So at the end of the inner loop, when we come out, the queue will be having two elements. So the next iteration of the outer loop will pick up these two nodes. So it keep going down level by level. So finally we get at the end of outer loop iteration 0, we have a list with one element which is 1. At the end of the second iteration 1, we have a list with 2 comma 3. At the end of iteration 3, we have numbers 4 and 5 and then we add all these three lists into the outer list output list and then we return that. Let's look at the flowchart. Input for this procedure is pointer to the root node and first we do initialize the out list which will be returned at the end of this procedure. Next we check whether that root element is null. If so, we return the empty out list. Otherwise we initialize the queue which always contain the elements to be processed in the next iteration and initially we add the root node to that queue and then we enter the outer loop. The outer loop checks whether the queue is empty. If it is empty, it will go out and return the out list. If the queue is not empty, then we do initialize the current level list and then count and index. The current level list contains will at the end of this inner loop, it will contain all the nodes present at that level. So what we do, this is the inner loop. So here first we check whether the index is less than count. If yes, that means there are some elements to be processed. So we dequeue the first element from the queue and add that value to the current level list. Then we check whether that dequeued node has a left child. If so, add that left child to the queue. Otherwise, skip it. Same way, if it has a right child, we add that to the right, or add the right child to the queue, and then we increment the index, and then we process all the elements at the count number of elements. Once that is done, we come out of the loop. So when we come out of this loop, this current level list contain all the nodes present at that level. So we add that current level list to the out list. So the out list basically an list of list. Okay. So then we proceed to check whether the queue is empty or not. If it is not empty, that means there are some elements in the next level. So we continue to repeat this until we reach the leaf nodes of the tree. At that point in time, the queue will be empty. Then we come out and return the out list. Let's move on to coding. First, the out list is initialized, and then I check whether the root is null. If so, return that empty out list. Otherwise, I initialize the queue with root as the only element in it. Then the outer for loop begins, which checks for queue is empty or not, and if it is not empty, then I initialize the cur level list to empty list, and then initialize the count variable to the number of elements in the queue at that point. Then the inner loop starts and it runs for count number of times, process the count, all the count nodes in it. So we are dequeuing the queue, first element, and then updating the queue. Then add the current element value to the cur level list. Then I check whether it has the cur level node. Next I check whether the cur node has a left child. If so, add that left child to the queue. Same thing, if there is a right child, that will also be added to the queue. When we come out of this inner loop, the cur level list will contain all the nodes at that level. Then we add that list to the out list. Finally, I return the out list. Next I'm going to run the test cases. Okay, all the tests are passed. Next I'm going to submit this program. Cool, it's accepted. Next I'm going to do the code walkthrough with sample input. We are given this tree and the root node is 5. So first the level order function gets the pointer to this root node and we check whether it is null. It is not null, so we are proceeding, and then there we initialize the queue with the root node. So the queue contains only the root node 5, and then we enter the outer loop where we initialize the curl level list, and then we get the count of the queue at that point in time, so which is 1. So in this inner loop process one element from the queue. So the first element we are dequeuing, assigning it to the cur node, and then we assign the value of that cur node to the current level list. So the current level list at the end of this 0th iteration is 5. And then what we do is we check current node as a left child. In this case it has 1, and we add that to queue, and then we check whether it has a right child. Yes, it is 4. So 4 is also added to the queue. So at the end of this first iteration the queue will be 1 and 4, and the current level list is 5, and when we come out of this inner loop we add that list, current level list, to the out list. So that's why we have that nested out list have only one list inside. That is first iteration of the outer loop where we process level 0 elements in the tree. Next iteration of the outer loop, the queue contains 1 and 4, and then current level is empty when we are entering the inner loop, and the first iteration of the inner loop we dequeue the element node 1 and assign it to the cur node, and then we add that value to the cur level list, and then we check whether it has a left child and right child. This node do not have any left or right child. Then we are proceeding to the next element, which is 4. Then we add dequeue that from the queue, and we add that value to the cur level list. So that's why we see the cur level list at the end of iteration 1 has 1, 4. After this we check whether that node has left child. Yes, it is 3, and then right child 6. So these two nodes will be added to the queue. So at the end of iteration 1 the queue will have 3 and 6. Then when we come out of this inner loop we add that level 1 nodes to the out list. So that's why at the end of iteration 1 we have 2 lists inside the out list. So one is 5 and the other list has 1, 4. So in the iteration 2 we have the queue elements 3 and 6. Sorry. Okay, so we have 3 and 6. So the inner loop dequeue each element and then check whether they add that to the current level list. So we see that in the current level list, and then it checks whether they have the left or right child. Both of them do not have any children. So at the end of iteration 2 the queue will be empty, and we added this list 3, 6 to the out list. So finally we have 5, 1, 4, 3, 6, and because this queue is empty we break out of the outer loop, and then finally we return the out list. Next I'm going to do the time and space complexity for this solution. Let's take this input for our analysis. So it has totally 5 elements. So in order to do the level order traversal, we have to traverse all the 5 elements. So at level 0 we have to traverse one element. At level 2 we have to do 2 elements. At level 3 we have to traverse 2 elements. Totally 5 elements, which is the total number of nodes in the input. So the time complexity will be order of n. So inside this loop we process each nodes in a particular level, and this loop we loop through as many number of levels present in that loop. So the outer loop runs 1, 2, 3 times, inner loop depending on the number of elements in the level. Next I'm going to do the space complexity analysis. So for the out list, basically for this problem we have to return a nested list which will eventually have the same number of elements as it is in the input. So we need to allocate space for those individual elements. So the space complexity is order of n element. So it is order of n. In addition to that, we need to allocate space for the queue which holds the nodes present in the next level. So for example, at level 0 we need space for one node in the queue. At level 2 we need a space for 2 nodes. For tree with the height level 2, so we need a space for 4 nodes. So this is for the case where for the complete binary tree. So in this case the left child this node 9 do not have any children, but if this is also has children, then this tree is a complete binary tree. So level 2 will have 4 elements. So if we extend that, for any tree with height h, the queue needs space for 2 to the power h. So the height is nothing but log n base 2 for a binary tree. So total space complexity is order of n plus 2 to the power log n, which is approximately order of n. Thanks for watching this video. Have a great day.